So the first part of completing the square that we did in, I guess, 9.2 part 1 of the notes, right, was a condition where a was equal to 1. But a doesn't always equal 1, right? So there's a couple other rules, and when a is equal to 1, let's recall we would have to take b and we'd have to divide it by 2 and square it. So we call that's the rule when a is 1. Right? But there's going to be a different rule when a is basically not 1. And when a is not 1, it's going to be something else. So then we have to ask ourselves, is a, let me see here, go back, is the value for a, and I'm just going to use capital A so we know that we're talking about, this first part of the thing next to the x squared. Is a perfect square? And we have to ask that question. And what do you mean by perfect square? Well, 1 times 1 is 1 squared. So that's a perfect square in a sense with 1. But we're talking about when a is not 1 and if it's a perfect square. Well, what's another perfect square? 2 times 2 would be 4. So if a were 2, right, that would satisfy that. What about 3 times 3? So a could be, I shouldn't say not when a is 2. So if a were 4, right, that would work. That's because 4 is a perfect square. And what about 3 times 3 makes 9, right? So if a were 9, what about 4 times 4 is 16? If a were 16, right, these are all perfect squares. Essentially these numbers. You could probably guess the next one. If a were 25. So that's 5 times 5. So if a is a perfect square, then we use a different rule than the b squared divided by 2. And in tiny print, it's right here. We're going to use b squared divided by 4 times a. So here we have in this example, right, here's the condition. A is 9, and 9 is a perfect square. So we have to use this different rule. So we take the value of b. Here's the value of b, right? It's going to be 6. So it's going to be 6 squared divided by 4 times a. How much is a? 9. So this winds up being 36 divided by 36, which is equal to 1. So we are going to basically add 1. We're going to add 1 to both sides because that's what b squared divided by 4a is. So it's going to be 9 squared plus 6x plus 1 plus 1. So now that we've done that, we can now factor this into, well, what are the factors of the perfect square? 9x squared. We're going to have 3x plus 1 squared. And that's going to equal 10 plus 1, which is 11. And now, again, because we've completed the square, we're able to now solve for x. So I take the square root of both sides, because that's the inverse operation of something squared. You're going to get 3x plus 1 on this side is equal to plus or minus 11, square root of 11. And then 3x plus 1 is basically equal to positive 11, or 3x plus 1 is equal to the negative square root of 11. And then we do the algebra. We subtract 1 from both sides, and you're going to get basically two answers for x. divided by 3, negative 1 minus the square root of 11 divided by 3, because we divide both sides by 3, and we subtracted 1 from both sides. So hopefully this makes sense. We're going to use this different rule when we're going to call this, this is like rule 1. We're going to call this rule 2 for completing the square. And I'm certain this will be a poster on the wall by the time you see these notes. So look out for that too if for some reason you can't remember any of this mess. On top you get 256, and on bottom you get 4 times 16, 64, and 256 divided by 64 is equal to 4. So we have to take this and we have to add 4 to this side and 4 to that side. So let's try that now. 16x squared minus 16x, and we're going to add 4 here is equal to 5 plus 4 there. And we already know that this is going to factor into basically something squared. And what is that something? It's going to be, 4x, and you see how this middle term is a minus, and this other term is a plus, so it's going to be minus 2, 4x minus 2 squared, and all that's equal to is 5 plus 4, which is 9. So from here, we take basically the square root of both sides, because that's the inverse of something squared. And you're going to get 4x minus 2 is equal to essentially plus or minus 3. And then from here, we're going to have to, add 2 to both sides, and then also divide by 4. So you're going to get x is going to be equal to 2 plus or minus 3 divided by 4. And what are those two answers? All right, 2 plus 3 divided by 4 is 5/4. And 2 minus 3 divided by 4 is minus 1/4. Minus 1/4. So we'll try another example in just a moment, and hopefully this is making a little bit of sense. So here we go. 4 is A, right? And we've already determined that 4 is a perfect square. So I'm going to use this formula, B squared divided by 4A, to figure out what do I have to add to this to basically make it a problem that I can use the square root to solve. So here we go. B is going to be 12. So I'm going to take 12 divided by 4 times 4, and it's 12 squared, right? So 4 times 4 is going to be 16 on the bottom and 144 on the top. And 144 divided by 16 is 9. So I got to add 9 there, and I got to add 9 there. If I add to both sides the equal sign, the equation is unchanged in the sense that they're both still equal to each other. But now I'll be able to use some algebra tricks to help me solve this. 4x squared plus 12x plus 9 is going to be equal to 5 plus 9. And then this here is going to factor, right? Well, what are the factors of the perfect square 4x? And it's going to be 2x. And what's the factors of 9 if it's going to be something squared? 2x plus 3 squared. And that's all going to be equal to 5 plus 9, which is 14. 14. And from here, right, we can take the square root of both sides. So you take the square root of that, take the square root of that. You're going to be left with 2x plus 3 is equal to plus or minus the square root of 14. And then from here, 2x, you subtract 3 from both sides is equal to a minus 3 plus or minus the square root of 14. And then last step, divide everything by 2. Our answer is x is equal to negative 3 plus or minus the square root of 14 divided by 2. And, this would technically be the full answer, but keep in mind, right, this is representing two different answers. One answer is negative 3 plus the square root of 14 divided by 2, and the other represents negative 3 minus the square root of 14 divided by 2. So let's take a look at what's on the next page. So if A is not a perfect square, right? That's 3, for instance, is not a perfect square. So we're going to have to multiply both sides by a value so that the coefficient will have a perfect square. And in this case, I'm going to multiply the whole thing by 3. Why? So I can get to 9, which is a perfect square, right? From this point on, you would, oh, my handwriting sucks. You would have a perfect square. And I'm going to draw a square. And all that means is, hey, that formula we just used, we can use it here once, of course, we've done this additional step, right? This additional step here, right? This is like an extra step. So now that we've done that, then you can basically do all the same things you did before, with the exception of having just one extra step, and then it all works out, and everything, and everybody's hopefully understanding what to do. So let's take a look at 2 examples when A is not a perfect square. And remember, perfect squares are 4, 9, 16, 25, 36, and so on. So here we go. A is definitely not a perfect square in example 11. So, and then there I go. I'm just going to draw a little partition to separate my work because as you've seen, right, some of these problems have quite a bit of work. So let's see. Then the first perfect square is 4. So half of what makes 4? So probably 8. So I'm going to have to multiply this whole thing by 8. And it might seem strange to do that, but it's just like the same concept. If I'm adding something to both sides of the equation, or I'm multiplying both sides of the equation by the same thing, you're totally following the laws of the math gods, and that's totally allowed in algebra. And sometimes you just have to do stuff to an equation to make it work out the way you want. So here I am, I'm doing stuff, I'm multiplying both sides by 8. How come? Because I'm trying to get to a perfect square. So 1/2 times 8 is going to be 4x squared. 8 times 3 is 24x. And you can see, right, this extra step, this is just one more step. Didn't really take me too long. That's going to be 112. And now I can use this, this b squared divided by 4 times a formula to figure out what to add next. So here we go. We got b squared. That's going to be 24 squared divided by 4 times how much is a? A is 4 in this instance. And that's going to give me what I'm going to have to add. So 24 squared, and this is why we love calculators. In the olden days, we'd have to do this all by hand. 4 by 4, 16, and then 576 divided by 16 is 36. So we're going to have to add 36 to here and here. So 4x squared plus 24x plus 36 is equal to 112 plus 36. And then, right, this is going to factor. It's going to factor into 2x, and then what's the square root of 36? Plus 6 squared. And then 112 plus 36 is equal to 148. So far, so good. We've got it to do everything we needed it to do so far. Now we're going to take the square root of both sides. You're going to get 2x plus 6 is equal to the square root of 148. And the square root of 148, your class set of calculators will simplify this. I've probably hopefully shown you how to simplify this by hand, but your calculator will do it. And from here we subtract 6 from both sides. 2x is equal to, and it's of course plus or minus, right? A minus 6 plus or minus 2 times the square root of 37. And you're like, how did he get that? Well, type this in your calculator, right? Type this here, and it should, this is the simplified version of that. And it's, of course, plus or minus, right? And then the next step, divide both sides by 2. And you might be tempted to think, oh, Lord have mercy, I must be done by now. Maybe, but you could actually simplify this further, right? And keep in mind, this represents 2 answers, right? The plus version and the minus version. And simplified, well, what happens when you divide everything by 2 here? Negative 3 plus or minus the square root of 37. And there you go, 2 answers. And that would be fully simplified. Next up, number 12. We have to make that 2x squared a perfect square. What's the next perfect square? Well, it'd be 4, right? So I have to multiply everything here by 2. Because 2 times 2 is 4. So 2 times 2x squared is going to give me 4x squared. 2 times a negative 4x is going to be negative x, or negative 8x. And then 2 times 16 is 32. So again, because a is not 1, and now a is a perfect square for me, I'm going to use this formula. And I'm going to get, negative 8 squared on top divided by 4 times how much is a? A is 4. And all that's going to be used to actually figure out what I have to add to both sides of the equation. So 8 times 8 is going to be 64. 4 times 4 is 16. So I'm going to have to add 4 to essentially both sides of the equation. So here we go. Let's go with a different color here. You're going to have 4x squared minus 8x. And remember, we're adding 4 plus 4 is equal to 32 plus 4. So far, so good. Now we're going to have something squared, and this is going to factor here into like 2x. And what's the square root of 4 here? Plus 2. And all that's going to be equal to 32 plus 4, which is 36. And now I can take the square root of both sides. Square root. You're going to get 2x plus 2 is equal to plus or minus. And what's the square root of 36, folks? It's 6. And now, right, minus 2 to both sides. 2x is equal to a negative 2 plus or minus 6. And divide everything, oops, I hit the flip the page button. Divide everything by 2. You're going to get x is equal to basically a negative 1, because what's 2 divided by a negative 2? Negative 1. And what's 6 divided by 2? Plus or minus 3. And keep in mind, right, this represents two answers. Well, what is minus 1 plus 3? So one of our answers is going to be 2. Right, x is going to equal 2. And what's a minus 1 minus 3? X is also going to equal a minus 4. So hopefully I don't scare you away with all this algebra, but this is the section 9.2 and exactly what we're doing in the book, and its understanding is critical to your success in chapter 11. So please study, come out for tutoring, and ask questions.